Okay, let me tell you how to evaluate a function in this video. We have a function f of x, and it is defined to be x squared plus 2x. So here f is the name of the function, and x is the variable representing the input value. And on the right hand side we have some kind of expression that gives you the output value. Okay, in this first example we want to compute f of 3. Okay, now if we compare the function and this problem, the difference is that instead of x we have a number 3. So the way we evaluate this function at 3 is to replace every occurrence of the variable x on the right hand side of the equation with the given value 3. So we have, instead of x here, we use 3, so we have 3 squared plus 2 times, instead of x we use the number 3. Then 3 squared is 9, and 2 times 3 is 6, so we have 9 plus 6, which is 15. So this is the answer. Okay, now let's look at the next problem. We have f of negative 3. When the given value is a negative number, we have to use parentheses. So when you replace x with the number, use parentheses and put negative 3 in there. Okay, so we have parentheses negative 3 squared plus 2 times, again, parentheses, negative 3. Okay, the negative 3 squared is positive 9, and 2 times negative 3 is minus 6, so 9 minus 6 is 3, so this is the answer. And what happens if we don't use parentheses? What happens if we don't use parentheses? If you simply remove the parentheses, see what happens? Well, this is negative 9 plus, and 2 minus 3 is negative 1, right? Negative 9 plus negative 1 is negative 10. And this is a wrong answer. Okay? So use parentheses. In fact, we could have used parentheses in the first example as well. It's going to give you the same answer. Okay, let's look at the next example. Okay, now here we have another function g, and this is defined slightly different. And if you look at the input values, they are not exactly numbers, but they are some kind of expressions or some other variables. So in this case, the rule is the same. We just replace every occurrence of the x on the right hand side of the expression defining the function with the given expression. So instead of x, we use parentheses negative a and take square of it. And minus 2 times parentheses negative a. If you simplify this expression, you'll get the answer. So negative a squared is positive a squared, and negative 2 times negative a is positive 2a, or plus 2a. So here is the answer. Okay, the next one, we have x plus 3 for the input. So replace this x with x plus 3. And we have x plus 3 squared minus 2 times x plus 3. Again, let me tell you again, use parentheses. Okay, first we want to compute x plus 3 squared. Well, how do we do that? Let me first tell you what not to do. I have seen people doing this. There are two terms, x and 3, so some people just take square of each term. So x squared and 3 squared is 9. They say that x plus 3 squared is x squared plus 9. But this is not exactly the correct way of simplifying this expression. For instance, if we have, say, 2 plus 3 squared, what is this? 2 plus 3 is 5, and 5 squared is 25. But if you take 2 squared plus 9, this is 4 plus 9, which is 13. And they are not exactly the same. So this is not exactly the correct way of squaring two terms. And here is the correct way of doing it. When you take square of two terms, this turns out to be x squared plus 2 times a times x plus a squared. So in addition to 2 squared terms, there's an extra term. So x plus 3 squared is in fact x squared plus 2 times 3, which is 6, times x, plus 3 squared, which is 9. Here's another way to do it. So x plus 3 squared is x plus 3 times x plus 3. And if you FOIL this out, x times x is x squared, x times 3 is 3x, and 3x is 3x, and 3 times 3 is 9. So 3x plus 3x, two terms in the middle, they make up 6x. And let me simplify this one as well. We have negative 2 times x, which is minus 2x, and negative 2 times 3, which is minus 6. Now we are going to combine like terms. We have x squared here. Now we have 3x terms here, 3x, 3x, and minus 2x. Together they make 4x. And constant terms, 9 minus 6 is 3. So here we have the solution.